Good day, Year 11 Methods students. This video is about Chapter 4b, Truncus. In this video, we'll be just doing the same as 4a. Start by investigating the basic shape, the basic function, along with its shape. Then we'll be moving on to the general function of the truncus, go through its key features, also discuss the difference between the hyperbola and the truncus in terms of its graph. And then we're going to do an example to show how those features are presented. All right, now let's get started. So firstly, the basic function of a truncus, you have y equals to 1 over x squared, or you can write as x to the power of negative 2. As you can see that since it is an x squared at the denominator, x squared itself cannot be negative, but since it's at the denominator, x cannot be equal to 0. Therefore, y will remain always positive. We'll again create this xy table. Okay, now you can see in comparison with the hyperbola, with truncus, that you can see the negative x and its opposite x values will give you the same y. Okay, so negative 2, when x equals to negative 2 or positive 2, y will equal to 1/4. Same as negative 1 and positive 1, y will all equal to the same value 1, except when x equals 0, which is undefined. Okay, and so the graph would look like a symmetrical one. Okay, it's a symmetrical graph. Instead of you have the top right and the bottom left. Now the truncus will have a symmetrical a graph, okay, with respect to the vertical asymptote here. Okay, I'm not, notice here I'm not saying a y-axis, because we all know that the after translated, the graph will always be corresponding to the isotopes instead of the axes. All right, now you can see that some students that they argue says, well, the truncus graph is just the hyperbola graph by reflect the negative part of the y value. However, this diagram shows you that's not the case. As you can see, the graph, the change of the gradients are a little bit different. Okay, so although here they have the intersection, which is 1, 1, and other than that, the overall shapes look similar but not quite alike. Okay, so you cannot just consider as this is reflected. Okay, you can't consider like this. All right, let's look at the general function. Okay, y equals to a over x minus h, everything squared, and plus k. So this is the general rule for truncus. As you can see that the denominator here is x minus h, everything squared, which is a perfect square. Okay, later on we'll discuss this. Again, a is the dilation factor, which is the same as the hyperbola in 4a. Okay, so again, let's quickly go through what is a. If the absolute value of a is greater, then the graph will be dilated away from both x and y axes. Okay, and if a is greater than 0, you will have the what we call the positive truncus. It's located on the top left and top right region with respect to the two isotopes here. Okay, if a is less than 0, you will get the opposite, right? Which is the graph got reflected, which is located at the bottom left and bottom right regions of the four region that has been separated by the two isotopes. Finally, we have the isotopes, which are exactly the same with the hyperbola case. So the horizontal isotope is where y equals to the tail here, k, and the vertical isotope is where x equals to h, which is the opposite of the number, the numerical term next to the x. Okay. All right. What I'm going to show you, it is the special feature for truncus. So just notice here for all the truncus that the denominator must be a perfect square form. Okay, so the denominator must be in a perfect square form. So notice here I give you these two examples. Okay, y equals to 1 over the this is the factorized quadratic trinomial x plus 1, x minus 2. Or if you have a complete square form. All right, now notice here I actually made a little mistake here. I supposed to write x plus 1, everything squared, okay? So notice none of these are truncus, okay? I'm going to use the decimals to show you what happens to those graphs. All right, again, this is what the truncus graph looks like if I have set the three parameters a, h, and k, or start this animation, and you'll see that, well, the trunk is actually moving accordingly, right? So and that the two isotopes is mainly separate the four regions, so that the trunk is actually moving around it because of the sign of A. Okay, so here is what I want to show you. Firstly, we have the y equals to 1 over x plus 1 times x minus 1, and we know that's x squared minus 1, but we have factorized it. Where you can see that this is not the truncus, okay? This is not the truncus. This is the truncus, okay? Where you can see that the difference are quite obvious, okay? Now, what if I change this? What if I got this, okay? In this case, it is not the truncus again, because the bottom denominator is not a perfect square. It's a completed square form because you have a tail, a constant, an extra constant. It's not fully factorized as a perfect square. And then where you can see that you lost one of the isotope, okay? I'm going to leave you to have a think about why this is the case, okay? Why you lost this vertical isotope if you get this second one, okay? If you're interested, you can also analyzing these two type of graph, okay? See the comparison. So this is actually you have two vertical isotopes instead of one, okay? Which is not the case that we have the truncus. Remember, the truncus only have one vertical isotope and one horizontal isotope. The first one, this one, we got two vertical isotopes and one horizontal. The second one, however, where you can see the second one, we only have one horizontal isotope. We lost the vertical isotope completely, okay? So one is we have extra vertical isotope, one is we're missing a vertical isotope. And then you can see both of the forms, none of them, the denominator are in a perfect square form. Okay, now let's take a look about how we're going to sketch a truncus. And again, there are three steps involved, just like the hyperbola. You notice that even the three-step format, it's almost the same with sketching hyperbola, except the step 2, I changed a little bit, okay? I changed the general graph a bit, okay? So here, let's see, we're asked to sketch this truncus. And the first thing is we're going to recall with the general rule here, y equals to a over x plus x minus h squared plus k. Notice what is a? A is negative 2, h is positive 3, k it is a positive 5. Okay, and then we can identify the two isotopes. The horizontal isotope is y, so y would equals to k, which is 5. And the vertical isotope, you have x equals to h is 3, so x equals 3. Okay, once you identify the two isotopes, you can start sketching these two isotopes on your plane. Okay, so give you a rough idea what are the regions. Okay, so you either top left, top right, or bottom left, bottom right of the isotopes. Step 2 is we're going to check the general shape to see any reflections involved. Mainly we're looking at the sign of A. So in this case, A is negative. So A is negative because A is negative 2. That's a negative number. And we know that when A is less than 0, the general graph will be located at the bottom left and right from the isotopes. Okay. So we're expecting to get a graph like this, okay? Notice here it's not the axis, but the isotopes here I'm sketching. All right. Then we move on to step 3. Step 3 is to determine the x and y intercepts. Firstly, with y-intercept that are exactly the same as we're trying to solve hyperbola case, you just need to substitute when x equals 0 and into the form, into the equation, and you work out that y would equal to 43 over 9. So you have the y-intercept 0, 43 over 9. However, when it comes to finding the x-intercept, when you substitute y equals 0, you notice here something happens, okay? Because you have the denominator being a perfect square, and then you have a negative 2 over this x minus 3 squared equals to negative 5. Here I'm going to use a little bit algebra trick, because you have the unknown sits at the denominator, and the numerators, both numerator and the quotient, that's a numerator, and the quotient here, which is the result here, they are both numerical. So what we can do is we can keep the numerator and swap the result, swap the result or the quotient with the denominator. Okay, so this is a little technique, so it can save us a bit of a time when we transposing the equations. And then we can get x minus 3 everything squared, that equals to negative 2 over negative 5, which is 2 over 5. Okay, and then we take a square root on either side, make sure you put a plus or minus, and we get these. Okay, x minus 3 equals to plus or minus root 2 over 5. So here you notice I have rationalized the denominator by times 5 both top and bottom, and I take a square root of the denominator. And then I move the negative 3 to the left, to the right, we got positive 3 plus or minus. So you have two x-intercepts, x3, which are 3 plus root 10 over 5, comma 0, and 3 minus root 10 over 5, comma 0. Then we're going to label all these points. On the plane, we have the y-intercept, we have the two x-intercepts, okay? And then we can sketch the graph, because the general shape looks like this. Okay, I'm trying to draw this, sketch the curve that passing through all these key points. Okay, and then like that. Okay, so this is the graph of the truncus. All right, now I hope these videos are useful. And then again, if you have any questions, make sure you ask me or come to the Mess Hub. Thank you. Looking forward to see you in the next video.